is going to be blood type O. And the dominant is going to be any blood type that's not O. So A, B, and AB. So a little bit of review again before we get started. We're going to use I, which means it's going to put an antigen on the red blood cell. So if you remember, those were little protein markers or flags. So every red blood cell will have a little protein that says, hey, this is blood cell A. Okay? And then we're going to have a little I that's going to be no antigens. So the big I means that an antigen is going to be placed on the red blood cell, and a little I means no antigens is going to be placed on the red blood cell. So we can have big IA, or we can have big IB. So we have two types of antigens that we can have. Okay? So we're going to start out and put in the genotypes that we're going to know for sure. So let's review what the genotypes for blood types are first. There are two ways to have blood type A. You can have one allele that plants the antigen on the red blood cell, and you can have a second one that plants it on the red blood cell. So two alleles that are going to put antigens on red blood cells. So that's homozygous. The other possibility is heterozygous, which means you have the one allele that's going to put the A antigen on the red blood cells, and the other allele doesn't code for any antigens. It doesn't make you any more or less blood type A. It just means that one allele doesn't code for antigens. If we look at blood type B, same scenario. Someone can be homozygous blood type B, or they can be heterozygous blood type B. Remember that the capital I means that an antigen is going to be put on the red blood cell. This is considered multiple alleles because we have the possibility of the A, the B, and the little I. And multiple alleles are patterns of inheritance when there's two or more alleles. More than two alleles, sorry. Okay? Then for blood type AB, there's only one possibility. The person has one allele that's going to put A antigens on the red blood cell, and one allele that's going to put B antigens on the blood cell. So that's the only possibility for someone with blood type AB. And then lastly, we have blood type O, in which there are no antigens put on the red blood cells. So we can put in anybody on our pedigree with these two genotypes, because that's the only possibility for their genotype. So blood type O would be two little i's, and blood type AB would be I sub A, I sub B. Okay? And just like in the other traits that we did, I'm going to put both possibilities for the blood types that are left. So generation 1, person 1 could be homozygous B, or they could be heterozygous B. Person 2 and 3, same thing. They can be homozygous, or they can be heterozygous. And then if we look at person 4, they're either going to be homozygous or heterozygous. And so here's where we're going to start doing our backtracking again. So if you look at generation 2, person 3 and 4 and their child, each of the parents had to give a little I to their child. So one little I had to come from the mother, and one little I had to come from the father. So that means that they can't be homozygous for their genotype. Remember, if you wanted to check that, if you crossed an I sub big B times I sub big B times I sub big A times I sub big A, all four possibilities, would be blood type AB. So it would be impossible for that to be their genotypes because they couldn't have a child with blood type O. Okay? Then we go over to, let's do person 1. Okay? And so they have a child with a little I. So number 3 has a little I. And so they couldn't have got the little I from the dad because he's blood type AB. He could not have donated the little I. So that means the mother had to donate the little I to child number 3. Because the father could only donate A or B and no little I. So that means the little I had to come from the mother. Okay? So then we look at person number 2. And we look at it, is it possible that they could be I sub B, or I sub B little I? Well, we don't know which one they would be. And so if we did the Punnett square crossing our parents, we would see that there'd be a chance for them to be the homozygous genotype and the heterozygous genotype. So we have to leave this person as they are. Now, if generation 2, number 2, had children and the children had blood type O, then we could figure out their genotype.